So far, when we talked about functions, we generally talked about functions as these top-level constructs or as methods which are part of structures. However, it is possible to create a function and actually store it in a variable. And in fact, variables are very amenable to the kind of approach of storing them in variables. Let me give you a very simple example. Let's say I have a function called say hello. Say hello doesn't do anything particularly clever. It just prints out hello. Now, when I use this function, I can certainly go ahead and call the function. So I can say hello, no arguments, semicolon, just like that. I run this and it gives me my hello. However, what I can do instead is I can create a variable with a let binding, which is going to refer to this function, say underscore hello. And then I can call the function on this variable, so I can actually apply the function call operator to this variable, thereby invoking pretty much the same thing. So this should give you a hint that it is possible to take an actual function and store it in a variable. And in certain cases, especially when you deal with higher level functions and that sort of thing, it's actually a very relevant thing to do. So let me give you an example. Let's suppose that we want to have a function which simply takes a variable, increases it by 1 and returns the result. So I can define a variable as +1. Now, when I want to if I want to define this variable in here as opposed to outside at the module level, what I have to do is I have to create something called a closure. And a closure is simply a function that's defined in line. So the way you define it is first of all by defining the argument. So in this case, I'm going to take a 32-bit integer. So I'm going to say that I'm taking a parameter called x, and it's of type i32. You'll notice that instead of round brackets, like here, for example, what I'm doing is I'm using vertical bars to delimit the actual parameters of the function. And then I can specify the function return value. Now the return value is an arrow plus i32 because I'm going to take x, I'm going to increase it by 1 and return it. And now here inside the curly braces, I can define the function body. In this case, all we have to do is do x plus 1 to actually return the value. I'm not putting a semicolon at the end of x plus 1 because that's what I'm returning, but I am putting a semicolon at the end of the declaration of +1. So what happened right now is I effectively made a function called +1, but this function is only going to exist inside the closures function. It's going to disappear completely, and it's not going to be available outside this function, whereas, for example, say hello is available both inside closures and inside main as well, and inside any other function that we might have. So now that I have this function +1, I can actually use it. So if I make a variable called a with, let's give it a more interesting value, what I can do is I can print line that this variable +1 equals the result. So I feed a and I get +1 of a. So that's how I feed in the value just by passing it as an argument. So x becomes x effectively gets the value of 6 by value. It increases it to 7 and it returns that 7 as a result. And when I run this, well, fairly predictable. 6 + 1 = 7. Okay, so this is a very simple example. Let's take a look at a more complicated example. Let's suppose that I want to have another function called +2, which is going to take an x again. But this time what I'm going to do is I'm not going to specify the type of the argument of the closure, nor am I going to specify any return values. Instead, what I'm going to do is I'm going to let the compiler figure out what those are for me. So I'm going to define a parameter x, and then I'm going to increase x by 2. So let's do it in a more complicated way. Let's make a mutable variable called z, because you'll notice that you can, the function itself, you know, everything that's between the curly braces, you can have any number of statements. So here I'm going to declare a variable called z, which will have the value of x, and then I will increase z by 2, for example, and I would simply return z. So this is a function that I've just declared, which takes a value, increases it by 2, and returns the result. So here, once again, I can print line the fact that something plus 2 is equal to whatever the result is. So I can feed in 3, and I get +2 of 3, which is 5, so I should get 3 + 2 = 5, and that's exactly what we get, as you can see here. However, let's make this a bit more complicated, because this function looks very similar to the function before. Let's imagine that this 2 here is actually a variable. So let's imagine that 2 is defined as a variable here. Now, what is going to happen if I replace this 2 by 2 like so? Well, one of the problems is that, well, it will run just fine. However, the real problem here is what would happen if I try to use 2 after it's been used inside this function here. And the unfortunate consequence is if I try to borrow this 2 like this, for example, I borrow it as mutable, what would happen is I would not be able to compile it. So it tells me that I cannot borrow the immutable local variable 2 as a mutable, but let's try to figure out why it is. You see, when I'm using when I have this closure here, the compiler figures out that we have a dependence on 2, and its default behavior is to essentially take over, to borrow 2 entirely. And after it's been borrowed by the closure, we can no longer use it at all. Meaning that, you know, it's not possible to use the variable 2 until we get the closure to release 2, so to speak. But unfortunately, that's not going to happen until the end of the function. So what can we do about it? Well, the only thing that we can really do is we have to make sure that the actual function that we made plus 2 gets destroyed before we get to this point. So how can we do that? Well, we can do it by just making a scope. So let me just put a curly brace in here. Let's put another curly brace in here. I'm going to simply indent all this code. So now what's happening is I've made a scope where I declare plus 2, I use it for my printout, and then as we go out of the scope, everything that's declared locally in the scope gets destroyed. So the closure that we made effectively gets destroyed, and therefore we can in fact borrow this variable and use it. And if I try to run this, you'll see that, well, we still have this little problem that we're trying to borrow an immutable variable as mutable, and the well, a simple fix here would be to simply put mut in front of the tube. And now this works. Now this is correct code and everything works just fine. So let me give you another example of how you would use these closures. And I want to stress that in the previous examples, we effectively passed the i32 by value. We took the value that we required, we passed it in there by effectively making a copy, and there was no problem. However, as soon as we started capturing something, like we started using the variable 2 inside here, it was essentially borrowed as a reference, and that's where we went into all sorts of problems. So essentially, it's possible to pass arguments in different ways. So you can pass the type T, like an i32, for example, and this is essentially a by value kind of passing, which means that you basically take the a copy of the variable, you make an entire copy of it, and you send it over into the function. And the other approach is, of course, to do it by reference, or you can do it by mutable reference. So let's take a look at how this would work. Now let's suppose I want to have a function plus 3, so let plus 3, but this particular function, what it's going to do is it's going to take the argument that is fed into this function, it's going to take it by reference, and it's going to increase the value by 3. So how would that look? Well, we're still taking an x. However, here, because I want to change the x, it has to be a mutable reference to an i32. So this is how we define the actual argument type. And then, of course, the body of the function is I have to sort of dereference the x and increase it by 3. So now, to use this function, what I can say is I can say let f equals 12, for example, and then I can call plus 3 on it. And here, obviously, this is, you know, I've just made something immutable, so I can try and sort of pass it as a mutable f, like so, for example, and then let's print line the f. So f is equal to this value. Let's put the f in here, and let's run this. Oh, seems to be a bit of a problem that we cannot borrow the immutable local reference, so of course f has to be mutable as well. So what we've done here is we've defined a function which increases the argument by reference by a value of 3, and so we take a mutable f and we pass a reference to it. I'm not sure this mutable here is actually no, let's leave it. I think we need it. So as I run this, we get an output f equals 15 because we fed f, not by value, we didn't feed it by value, we fed it by reference. If I were to change this to an ordinary by value call, like an I32, for example, obviously I would have to get rid of the star here and get rid of everything here. But then what would happen is we would plus 3, but the result is that of increasing a temporary variable called x by the value 3. And I'm not sure this would work either. Let's see. Yeah, so reassignment of immutable variable x. So this is how you actually define it. You put the mut in front rather than towards the back. So in this case, we're having a local variable, mut x. However, if I run this, you'll see that the value is still 12 because we just fed a copy of it into a lambda and we didn't change the original value. So this is how you work with closures.